In this video, we will introduce you to key features that help you simulate molecular biology procedures in SnapGene. SnapGene is the easiest and fastest way to plan, visualize, and record your core molecular biology procedures. Today, we're going to focus on features that help you visualize in SnapGene. Okay, so let's jump into it. First, let's take a look at the map view. I have a DNA file open here containing the PUC19 plasmid sequence. Because this DNA sequence is circular, I can change the view from circular to linear format for ease of viewing by selecting the Show Horizontal Map button. You can easily annotate open reading frames or sequences of interest by creating a feature. By default, SnapGene automatically annotates features when creating or importing a new sequence. But features can also be added manually by simply selecting or highlighting a region of interest. For example, I will annotate this open reading frame as a feature by selecting it and going to Features, Add Translated Feature. I will call this feature LACZA, since it codes for the LACZ alpha fragment of the beta-galactosidase gene. In the sequence view, you can use the side toolbar to show or hide features, translations and open reading frames, restriction enzyme sites, primers, and DNA colors. You can use the compact view to show just the top strand sequence colored according to features. The split window button at the bottom enables you to split the SnapGene window into two. This is useful when you want to view two different tabs at the same time. For example, you can view the map view and cross-check the DNA sequence with sequence view, all within the same screen without the need to switch tabs. By going to the Features tab, you can sort the list of annotated features by name, location, size, color, directionality, or type. You can also select the features that you want to be made visible on the map and sequence view. Visualizing restriction sites in DNA sequences is intuitive with SnapGene. Restriction sites are clearly displayed on or off with the click of the Show Enzymes button. In the Enzymes tab, you can choose from a range of enzyme sets or use your own enzyme set. Cut sites can be displayed as numbers or lines and sorted by name or frequency. As well as enzyme and features, SnapGene also defines primers that can be created and highlighted. Primer binding regions can easily be seen in the sequence view. You can even change the primer color by right-clicking and selecting Primer Color. To learn more about the primers in the file, head on over to the Primers tab. Easily sort the list of hybridizing primers by name, length, color, binding sites, directionality, or melting temperature. For projects involving one or multiple steps, you can see an automatically generated graphical history of your DNA construct in the History tab. For example, in this file, you can see that I simulated PCR to add two restriction sites onto an EGFR promoter, which was then inserted into a PGL4 plasmid containing a luciferase reporter. I can easily recover ancestral sequences as a separate file by simply clicking on them. Working with large sequencing files is also not a problem for SnapGene. Here I have the complete sequence of Candida albicans chromosome 4 open, which is 1.6 megabase pairs long. By clicking on the Zoom Controls option, you can easily adjust the zoom factor and sliding window display using the versatile controls to quickly navigate around the sequence. So that wraps up this introduction to visualization features in SnapGene. For more information about simulating genetic manipulations such as PCR and cloning in SnapGene, check out the other tutorials on the SnapGene website. If you found this video useful, please leave a like, it really does help support the channel. If you've got a question, pop it down in the comments below. Also, consider subscribing for more weekly tutorials.